Hello, everyone. In this week, week 13, I will talk about error correction, error detection, and we will introduce a couple simple error correction detection code. And then we will also work on quiz 3 for error correction, error detection. So some of you might have learned this from your 1400. If you took my 1400, like maybe not last year, maybe last year, so I cannot remember, but some of my 1400, sometimes if I have time, I covered this topic in the 1400. So some of you have learned this a little bit, some of you haven't learned this, but we have to make sure everybody after 2400 know what is error correction, what is error detection code. So this is a quite basic concept for information theory and for communication applications. So anything related to communication, computer arithmetic applications related with communication, they're related with error correction, error detection. So this kind of technique is actually used in your real life every day. So it's pretty important. It's kind of like a separate topic from the computer architecture part. It's not really talking about the hardware organization, the hardware architecture, but this kind of concept is also is really important for your future classes. For like in general computer science theory, a lot of applications are related with information theory. So you will be using error correction, error detection for many times in future. So we would like to cover this topic in this class, and that's our goal for this week. So I will first in this video talk about what is error correction, error detection, and what is parity check, in this video. And then I will talk about what is error detection and talk about the examples of Hamming code, 7.4 Hamming code in the next video. And I will have one more video to go through the quiz 3 with you and work on some similar problems of quiz 3. And then after you watch that video, you can start to work on quiz 3. It will be much easier for you to get everything done using quiz 3's video to help you. Okay, so we will start with what is error correction, what is error detection. And I linked a couple material here. So I linked some material here. Did I share my screen? Oh, yes, I did. Good. So I linked some material here. So, and also I put this in your quiz. So when you work on the quiz, then you could easily see the link, and you could check the reference material if you haven't got a chance to watch the video. So you could check the reference material as well. But is here as well. So let's first look at what is error. So in any application of communication, of course, there's always sometimes you need to deal with error. We do not lack error, of course, but there are always sometimes you need to deal with error. So what is error? Suppose one party is trying to transfer something to another party. So this is the basic, structure of the communication. So either your cell phone, your computer, or whatever device could transfer a piece of message, send a piece of message to another device. And as long as they're computers, then they're communicating in the binary message, right? So the binary message are basically constructed by all the binary bits, zeros and ones. And suppose a 0 bit changed to 1, or suppose a 1 bit changed to 0, then this is considered to be an error. So pretty straightforward, right? However, I mean, this is a really important concept. If you could fully understand that's the truth of the error, then we could determine what we want to do in future. So what do we want to do with the error? Of course, we want to know if there is an error. We want to correct the error if we can find the error. So then here comes the error correction and error detection. So error detection codes means the method we use to detect, to figure out, to find there is an error or not. So the error correction means if you could find the error, then you would like to correct the error, right? And it's pretty interesting here. So if I ask you what's the biggest difference between error correction and error detection, then of course, for me to detect the error, then it simply just means, can you find the error or not? For me to correct the error, so you have to find where is the error in order to correct it, right? So if we would like to correct the error, then we of course need to know where is the error. Suppose you have a message with many bits, 00111, 00111, things like that, and you don't know where is the error, there will be no way for you to correct the error. So we have to know where is the error in order to correct the error. So the biggest difference between the error correction and the error detection codes is the error correction code has to both correct the error, both find the error and correct the error. So the error detection code is only able to find the error, find the location, sorry, not find the location error, find the, figure out if there is an error or not. So the error detection code is only able to figure out if there is an error or not. But the error correction code should both find if there is an error or not, and second, correct that error. So if I know there is an error, how can I correct the error? So this is an interesting question. If I know there is an error, so you have like a few bits, 0101, things like this, and if you know there is an error, how can you correct the error? So it's really tricky question, because if I know there is an error, there's no way for me to correct the error because I do not know where the error is. First bit, second bit, third bit. I don't know where it is. However, if I know there is an error and at the same time, I know where the error's location, where's the error's location. For example, if I know D2 is wrong, then I will be able to correct that because I simply have 0 and 1. I only have 0 and 1 in the binary sequence. So if D2 is 1, if D2 was wrong, I can just flip that bit. I can simply flip that bit, switch that bit from 0 to 1, from 1 to 0. And that way I will be able to correct the error. So as long as I know where the error is, I will be able to correct the error. However, the error detection code does not know where the error is. The error detection code means you only know there is an error or not, but you do not know where the error is. If we know where the error is, then we will be able to correct the error because we can simply flip 0 to 1, flip 1 to 0. And then, it has to be one way or the other. So we are able to correct the error as long as we are able to find the location of the error. So this is the general concept of error detection, error correction. And then let's look at what is parity check. So the simplest type of error detection code is called parity check code. Parity check code. So what is parity? What is parity check code? So basically, if we would like to add a couple or some extra bits to the original message, and the whole bit sequence after you add some redundant, some extra bits is called a code word. So a code word means there are some original message, such as this one, you have D0, D1, D2, D3, D4, D5, D6. So your data basically has 7 bits in it. And all the 7 bits here are the message, are the original message bits. And suppose we add one extra bit, to make a whole code word. And then the extra bit we add, this is called parity bit. This is called the parity bit. So the parity bit here and the original message bits all together is called a code word. So it's pretty straightforward. So why you want to add extra additional bits? Just as an example, so I do have it here. Suppose the original binary code is 000, and from the left-hand side to the right-hand side, we have 3 bits. And if we call the most left bit as the most significant bit, and the most right bit as the least significant bit, and we could add the parity bit on the left-hand side, on the right-hand side. Suppose we're only adding one extra bit. There will be 2 different ways you could append one extra bit to the original bit. So you could either append it on the left of the most significant bit or on the right of the least significant bit, right? So suppose we just do it on the most significant bit and we append one extra bit on the left-hand side. And then what will happen? So let me switch to the iPad. All right, I just switched to the iPad. And let's look at the parity check code. So there are 2 different ways I could append extra bits to secure to detect if there is an error or not. So one is called even parity code, one is called odd parity code. So what does that mean? It's easier when we look at the example. So suppose we have the original binary sequence that's 000. So I have 3 bits. As my original binary message. And this is the most significant bit, this is the least significant bit. And we would like to append one extra bit on the left-hand side, and we call this as the parity bit, So the even parity code means you would like to add a bit here, and you know you can only add either 0 or 1, right? And I have to add 0 because I want to maintain there's the even number of 1s in this sequence. So originally I do not have any 1, so I will have to add a 0 here, and then the number of 1 will maintain even because the number of 1 the number of 1s in this bit sequence is actually 0. So it is an even number. So if there is even number of 1, you count the number of 1s in this bit sequence, and then you would like to make sure it is an even number. And suppose I get my original bit sequence is 001, and the extra bit, the parity check bit I add will have to be 1 because I want to make the number of 1s to be even. So originally I had 1, 1. So I'll have to add 1 more 1 here to make even number of 1s. So if my original message is 011, so I had 2 1s. So the extra bit I add will have to be 0 because you do not want to change the number of 1s because you have even number of 1s. So this is called even parity code. And then if you understand this, then you know what is odd parity code. So suppose my original binary sequence is 000, and I would like to make sure the final code word has odd number of 1, So I will pad 1 here. And suppose the original message is 001, I would like to make sure the message has odd number of 1s. So I already have a single 1 here, so I will not add a 1, I will add a 0 as my parity check. And suppose the original message is 011, so I had even number of 1s. So the extra bit I add here has to be 1 because I want odd number of 1. So I want 3 1s. So this is how the parity check code is made. And what's the usage of that? So why you want to add an extra bit? So if this is your original message, by adding an extra bit here, then you could send the 4 bits out together. And you tell your friend, well, I send you an odd parity code. And then everybody will know, okay, so we're looking for odd number of ones. And suppose I got this code, which is 0001, and I had odd number of ones, and that basically means, okay, maybe it's the original message. Suppose I got the message 0001 changed to be 0011, changed to be 0011. And that actually means this bit had an arrow. This bit had an arrow. And then suppose your friend got 0011 and he simply count, oh, there are 2 ones here, and you told me it should have even number of, it should have odd number of ones because it's an odd parity check code, and I got even number of ones. So that actually means there is an arrow. There is an arrow in this message. There is an arrow in this message. So what we did is trying to spend a little bit more bit and try to secure the whole message. And the extra bit we add is kind of like trying to guarantee certain feature of this message. And after you send out this message, your friend should be looking for the same feature, the same feature. And if they were not able to find the same feature, then of course there is something wrong. There is something wrong, right? So we are able to figure out if there is an error or not. If there is an error or not in this kind of message, by doing the parity check, right? And then you may have a question, well, suppose you got, so the message you send out should be 0001, and suppose 2 bits of them got wrong, and then you will get 0111, you get 0111. And your friend knows this should be an odd parity code, and you still have odd number of ones. You still have odd number of ones. So that will not work. That will not work, right? So every code has its own ability, And if we have like this 3 bits, we have this 3 bits like this, and we add 1 extra bit here, we add 1 extra bit here to secure the original 3 bits, and we are only able to detect, you know, the 1 single bit error, 1 single bit error. If there were 2 bits wrong at the same time, then it will out of the detection ability. It is out of the detection ability of this kind of design. And of course, you could add more bits. You could add more parity bits to secure more original message, right? So of course, then your bit rate, your efficiency of your transmission is lower. Originally, you only need to send 3 bits to represent 3 bits information. And then you have to send, if you want to maintain the security level, you have to add 1 extra bit, to secure, to detect 1 single bit error. And if you would like to detect multiple bits error, then you probably need to add more bits. So this is fair. If you want higher security, then you probably want to spend more transmission, right? So, all right. So this is error detection. And we have introduced the really basic, most popular code called parity check code. And how to use parity check to detect an error. This is in your quiz 3, you will have a couple questions related with parity check code and how to make the parity check code. All right, so we will talk what is error correction in the next video.